In this lecture, we'll introduce a key programming paradigm known as object-oriented programming, or OOP for short. We're going to explore what OOP is, how it compares to procedural programming, and some basic terminology like classes, objects, attributes, and methods. By the end, you'll understand the fundamental concepts of OOP and how they relate to real-world examples. Let's start by discussing what object-oriented programming is. In simple terms, OOP is a programming style that allows us to model real-world things in our code as objects. These objects have attributes, which describe their state, and methods, which define their behavior. This way, our code becomes more organized and reusable, especially when dealing with complex systems. For instance, think of a car in real life. It has attributes like its color, brand, and engine type, and it also has methods or actions like starting, stopping, or turning. With OOP, we can model all these in our programs. Now let's compare OOP with procedural programming. Procedural programming is a more traditional approach, where we write a series of instructions that the computer follows step by step. Imagine cooking a recipe. Each instruction is a step in the procedure. While this is great for simple tasks, it can get messy when the program grows larger. You might find yourself repeating code or struggling to keep things organized. On the other hand, OOP helps break down these instructions into smaller, more manageable pieces by grouping them into objects. Think of it like organizing your kitchen. Instead of having all your tools and ingredients scattered around, you have neatly organized cupboards, drawers, and sections for each task. This organization makes your program easier to manage and understand. Next, we need to introduce some basic terminology to get comfortable with OOP. The first term is a class. A class is like a blueprint or template for creating objects. For example, if we're working with cars, the class would describe what all cars have in common, like their make, model, and the ability to start or stop. Now, when we use this blueprint to create a specific car in our program, that's called an object. So while the class is the general idea of a car, an object would be one specific car, like a red Tesla Model S. Classes also have attributes. These are the data that describe an object. For the car example, attributes might be the color or engine size. And finally, methods are the functions that operate on the object's attributes or perform some action. For a car, methods could include start or stop. To help solidify these concepts, let's take a look at a real-world example in Python. We'll create a class for a car. Let's open up VS Code and create a new folder called OOP to keep the examples for this new section organized. Inside that folder, I'll add another folder called Intro for this current lecture. Then, I'll create a new Python file named car.py. In that file, we'll develop our car class and work through it step by step. First, we define the class car. Inside a class, we have something called the init method. This is a special method in Python that runs when we create a new object. It initializes the object with the attributes we provide, like make, model, and color. Then we have two methods, start and stop. These methods define what happens when we perform these actions on a car. Let's create an object from the car class and provide the necessary data for its make, model, and color. Now, we can use the start method on our myCar object to mimic starting the car. When we run the script, we'll see this output. The car has started. Great, we've successfully created an object, our red Tesla, and called the start method on it, which prints the message that the car has started. Now that we've seen an example, let's quickly summarize what we've covered. We learned that OOP is a style of programming that models things as objects with attributes and methods. Procedural programming works step by step, while OOP groups related actions and data into objects, making code more organized. We explored classes, objects, attributes, and methods. We built a simple car class with attributes and methods, then created a specific car object and used its methods. That's it for Introduction to OOP. OOP helps us organize and manage our code better by structuring it around real-world objects.